All right, in this video lesson, we're going to learn about a concept in chemistry called the mole. Before we talk about the mole, let's just look at different ways that we define a number of things in our daily life. So we all know that a dozen means that you have 12 of something. So a dozen donuts is 12 donuts. A baker's dozen is 13 of something. So you get a baker's dozen of cookies, you get 13 cookies. A pair is 2, so a pair of shoes means that you have 2 shoes. A ream of paper means that you have like 500 pieces, so a ream is 500, and a gross means that you have 144. Okay, so these are all ways that we define a number of things. In science or in chemistry, we have this unit called the mole that we use to define the number of atoms and molecules that are in or that you are working with. So when we're talking about atoms and molecules, they're so tiny that we can't quantify them by saying we have a dozen molecules, or we have a pair of molecules, or we have a ream of molecules, because you can fit hundreds and thousands of molecules in or on the tip of your finger. So scientists use this unit called the mole to define the number of atoms and molecules that can be observed, measured, or handled. So basically, instead of counting a dozen atoms or a pair of atoms or a ream of atoms or a gross of atoms, scientists count atoms, molecules, and elements using the mole. So we count our atoms, molecules, and elements using a mole. When we count donuts, we say we have a dozen donuts. We are saying 1 dozen equals 12 donuts. When we're talking about the mole, we say that 1 mole equals 6.023 times 10 to the 23 items. And so the items can be atoms, molecules, or elements. This number, 6.023 times 10 to the 23, right here, is called Avogadro's number. Oh, that's a no. Avogadro's number. So this number, Avogadro's number, was figured out by this guy named Avogadro. And what he determined is that this 6.023 times 10 to the 23 is exactly the number of atoms in exactly 12.000 grams of carbon-12. So if we were to weigh, or if we were to take 12 grams of carbon-12, it contains 6.023 times 10 to the 23 atoms. So this unit mole right here has the symbol. We're going to come down here maybe. The symbol of N. And so N equals number of moles. And the unit that moles is measured in is the mole. So 1 mole is measured in moles. It has a symbol N, and there is 6.023 times 10 to the 23 items of whatever you have in 1 mole. So, for example, 1 mole of sodium atoms equals 6.023 times 10 to the 23 atoms. But if you have 1 mole of water molecules, you also have 6.023 times 10 to the 23, but this time you have molecules. If you had 1 mole of elephants, you would have 6.023 times 10 to the 23 elephants. If you were to take a mole of any element or compound and measure out its mass, you'll find that it has the same mass as the atomic or molecular mass of that substance. So I think we'll write that. So for example, if we have the atomic mass of carbon atom, it equals 12.01 atomic mass units. But if you were to take 1 mole of carbon and measure the mass, so the mass of 1 mole of carbon, you would find that it weighs 12.01 grams. So basically, it has the same number. Oh, where am I? Same number, but different units. And this is the same for any substance. The molecular mass of a water molecule is 18.02 atomic mass units. And if you measured 1 mole of water, it's going to have a mass of 18.02 grams. So the fact that there's this relationship between the atomic or molecular mass and the mass of 1 mole of the substance results in this concept called the molar mass. Okay. And this molar mass is the mass in grams of 1 mole of a substance. And it doesn't matter if it's an atom or a molecule or a compound, it's the mass of 1 mole of a substance. So our molar mass has a symbol, which is a fancy cursive M. And we measure the units of molar mass in grams per mole. It also can be written like this, grams over mole. Again, our molar mass is the same number as atomic or molecular mass, just different units. So our molar mass of carbon, same number as molecular mass, just different units. Grams per mole. Our molar mass of water is the same number as molecular mass, but again, units, grams per mole. Okay, and so just note that our unit is missing the E on purpose. Okay, so this is the end of our introduction to the mole video lesson. We will move forward in our next lesson where we will talk about how to do calculations involving the mole. So there's a relationship between the mass of a substance, the number of moles of the substance, and that relationship is the molar mass. So if you have the mass of the substance, you can figure out the number of moles if you have the number of moles of a substance, you can calculate the mass of a substance using our molar mass as a conversion factor.